Okay. All right. So the next thing that we're talking about is applications in forestry. Here again, as I told you, that I will be discussing only the most important or the mainstream applications of remote sensing and GIS, and discussing anything beyond this will be out of the scope of these classes. But I am confident that after you listening to different application, what are the different application, and a little looking into what other people are doing, I mean, these are not the only best papers, these are the ones that I have referred to, but I would really want you to identify more papers that are more relevant to the kind of work that you are doing or you might be doing in future. So applications in forestry, when we talk about forests, a natural forest, it is more it is said that it is at a higher risk from human encroachment than any area that has been converted from natural forest to human plantation or agricultural areas. I'll make that statement again. Any natural forest is at a higher risk, is at a higher threatened risk as compared to any area that has been captured by humans and it has been modified by humans. Either they are growing some plantation, some crop there, or they are taking some kind of plantation. All right, keep this in mind, which means that there are different uh, factors that are threatening this natural vegetation. All of them are not really human made, but there are many of them which are human made. For example, we talk about forest fires. They were natural, but now we also know that forest fires are um, set, or rather they have causal factors within human activities. um, so all these, considering all these risks, we will look at some very basic and most important remote sensing GIS applications in forestry. The forest mapping and inventory. When we know that there are forests existing, natural forests existing, we would want to map them. What is the total area that they are covering today? Then maybe somebody after 50 years would want to know, okay, if some 50 years back this was the aerial coverage and today this is the aerial coverage. So which means we want to prepare baseline data. We want to know how much of the natural forest is covering um, an area, proportion of an area, and we want to make an inventory. That means we want to note down each and every detail. What are the different types of trees that are found, which type of trees are found in which portion of this forest, which portion of this forest has older trees, and which areas have maybe forest gets discontinued. We want to create an inventory. We want to keep whatever we observe about these forests, to the extent that we might also want to know which kind of uh, fauna really lives in a certain kind of in a certain part of forest and things like that. So all this requires uh, noting down how there are changes happening in the environment, what is the total cover, and how much of biomass this particular mm, forest holds. So I wouldn't just call it measuring timber volume within that area. I would say how much of biomass this particular forest carries in which part of its region, and also to categorize the species that are making up this forest. So all this require again remote sensing and GIS, because it might be very difficult for us to crawl through each and every square meter of this forest, and remote sensing data is wonderfully able to do this for us. Now the next is fire management. We're talking about forest fires, which were essentially natural happenings, but then now we also know that it is because of human influence as well, isn't it? So we want to analyze what is the topography of the region. We would also want to identify which portion of that particular forest has fuel that is required for the forest fire to migrate from one place to another, or to even sustain. There has to be enough fuel that is that is what we call biomass, maybe dry litter or branches and things like that, which are not which are dry, so that they will catch fire instantly, and that fire will sustain such that it is able to dry off the nearby vegetation, and then set it on fire. I hope you're understanding this. See, the entire forest might not be serving as biofuel. That means what? It might not be completely made up of dry litter, dry branches, which are capable of catching fire quickly. But if this dry mass is available in sufficient quantity, such that the fire sustains for longer duration, as a result of which the peripheral forest, which might be wet, which might be having some moisture and is not readily available for catching fire, that will also become dry. So that will also absorb the heat, because of which moisture will go off, it will get evacuated, and what will happen, it will also set on fire. So this is the way a forest fire will sustain for longer distances, longer treks. And this is what we need to know. And when we want to know this, it is very difficult for us to do it by personally going to the field every time. We need to have some reconnaissance about the area, and that is where we talk about fuel biomass, measuring how much of fuel biomass, or perceived, sorry, not perceived, but essentially measured a proxy of this fuel biomass is present. And then moisture data is also required, such that we will be able to either prevent or manage the fire risk. If we are not able to prevent it, then we should be able to at least manage the fire risk by maybe um, showering over, artificially raining over a certain part of the forest, make it a little more moist, or felling some trees, such that we form a buffer zone where the forest fire gets prevented, and things like that. So all this will require remote sensing. All this is where remote sensing is used. You will find many papers wherein people are sitting in India and they are studying the forest fires of Amazon forest, um, and so on. So think about it. They are not really sitting in the same continent, but they're studying here. They're sitting here and studying past fire incidences, or environmental risk factor of these forests, either in whole or in parts and parcels. So they are not going to the field. That's what I'm saying. How they are not going to the field? They don't require, because they already have some proxies, some signals that they take from other parameters like moisture content and things like that. Then next is deforestation monitoring. Forest fragmentation is always the predecessor of deforestation. Before deforestation happens, there happens one more event that we call forest fragmentation. What exactly is forest fragmentation? This is where, for example, here you will see this is a continuous. Yes. So I was talking about forest fragmentation. So naturally, no, forests are continuous features. Naturally, they were continuous features. They were uninterrupted. They were changing from one kind of forest to another, maybe from matured old forest, deciduous forest, to shrublands or to grasslands, and so on and so forth. But they were essentially continuous. But these continuous forests, uh, when they are used, or when they are partly cut in a track to maybe lay down a railway line, or to lay down a roadway line and things like that, then what happens is that the forest becomes discontinued. Now, as a result of which, what happens is that along this track that has been newly developed, and making this forest discontinuous, this track acts as a pathway through which, on the periphery of it, more and more destruction to the forest will happen. So as a result of which, this path or this track will keep widening and widening at the expense of the forest land. This is what we call forest fragmentation. Now, this forest fragmentation will will become more rapid when there will be such more tracks showing up away from or branching out away from these tracks. So as a result of which, you will see that earlier this one forest was divided into two parts. Now it will be divided in multiple parts. So as a result of which, you will see forest fragmentation and ultimately deforestation. Deforestation um, comes essentially after fragmentation. So forest mapping and inventory, so this for this particular map, no, it shows you which are the areas that are very high in forest fragmentation. It's the same map coming here. Here again, you are looking at forest fragmentation susceptibility classes, which areas are more susceptible to forest fragmentation. In this, what you see is where the forest fragmentation has already happened, that has been mapped. It is a status that is mapped. Here, what might happen, what is likely to happen, that is mapped. Both is done using remotely sensed data and again integration with GIS. So here what you see is a standard weight for this mm, forest fragmentation is made, and this weight is then classified based on what we call a natural break, or a natural break is also called graphical break. These are the ways in which you classify your continuous data. Just read a little about it. For example, there is equal interval, that is maybe 10 to 20%, 21 to 30%, 31 to 40%, like that, an equal interval break. Then you also have something called graphical break. Whenever you put all the population in a cumulative frequency, what you will see is that there are slopes. So the curve goes sharp and then changes its slope, changes its slopes again. If you have ever worked with something called graphic mean, mode, and median, then you will know what exactly I'm talking about. So these breaks serve as one class. The upper limit of this slope break and the lower limit of the slope break acts as one class, and that is how this particular analysis is done. Most of the time, you do that. And most of the time, that is more. More of a grouping factor that you use. So in this particular map as well, you see areas which are very highly susceptible to forest fragmentation. Okay, these orange ones, you will see them here. That's the only color there. Then you have this peach color, lighter pink color, high susceptibility. You will see together it is amounting to around 18.5, 18.5%. Sorry, not 18, 28.5%. And then you have yellow areas which are along the periphery of these high and very, very high susceptibility to forest fragmentation. And then you have low and very low. Okay, so this is likely to happen, that has been predicted. This is the status, that means it has already happened. What is already happened, you take it from the spectral signatures from the satellite data, and what is likely to happen, you find it from proxies. Write this word down somewhere. You will some or the other day thank yourself for um, finding out what exactly proxy is. Write down proxy, Proxy. If you were sitting in a class and you were asked to write on, or asked to give your attendance by signing on the attendance sheet, and your friend was not there, you would go for a proxy sign, isn't it? Proxy means on behalf of somebody you are signing there. So, in the similar manner, here on behalf of forest fragmentation susceptibility, other factors are giving indication that these areas are highly susceptible or these areas are low susceptible. For example, there's a road is a proxy to show you that these areas which are surrounding it, no, they are highly susceptible to fragmentation. Okay, so that is it about forestry and agriculture. 4 minutes away from ending this class. If you have any question, please ask. You will see me keep quiet. If you don't have any query, you may go ahead. Have a great evening. Let me see you tomorrow evening sharp at 7, sorry, 8 p.m. So tomorrow we are going to talk about urban planning and water resources. If possible, we will also accommodate climate studies, because climate studies will be a smaller topic. Also, biodiversity and wildlife monitoring will be a smaller topic. It'll be difficult to take up all throughout. Those of you who are present here, can you also drop me which is your field? Like, for example, you're from earth